So today we have all these batteries. Let me show you what I've been working on. I have this shelf and companies have been sending in batteries for review, and this is not all of it. This is just a portion of the batteries. My thought is we can test these batteries, we can test the capacity of them, we can tear them down, but that doesn't give us information about how long they will last, if they will die in a week's time, if there will be issues with them over a period of time. And I had to figure out something to do with these batteries. So my ideal is I'm gonna put them on the shelf, and I've installed bus bars up here, and I've installed bus bars down on this shelf. So I've got two shelves that have bus bars, and I'm just gonna put them all in parallel. What could go wrong, right? And then on this side, I have a little board where I installed a solar charge controller. We've got an inverter, and we've got the new junk tech shunt, which I think is gonna work fantastic on this battery shelf. There's the little control box for it back there, and then there's the actual shunt box. So connecting to the two bus bars, I've got 2-gauge wire that connects from here, goes down, and it connects to those bus bars. I've got the main negative that comes off this one and goes over to my board that has all my devices on it. And then the main positive comes off of this portion and runs here to the board. And I'm gonna have like crazy amounts of fusing. So there's a fuse on the positive that comes from the top bus bars, and it terminates here. So there's a fuse on it right there. Then for each battery, we will have a fuse. So if anything goes wrong, if any one of these batteries shorts out or anything like that, its fuse will burn and we don't have a problem. So everything will have a fuse on it. I don't think I can think of anything else that could possibly go wrong. I mean, I know it sounds wrong to wire up a bunch of random different batteries in parallel, but I think it's gonna be fine. We're definitely gonna find out if it is. So let's install the first battery up here at the very top, just to get the system energized. So we do have an inverter in the system. So on the very first battery, we're going to for sure pre-charge it with this resistor. That should be long enough. Got a little bit of a sparky. First battery is in place. So let's go ahead and add the second battery, which will be this Time USB Sturdy Edition. And the reason why I'm gonna go with this one second is because I've actually fully charged this one, and I fully charged this one. So they won't have there will be no dangerous transfer of power or current when I hook them together. And that one, maybe we'll push it all the way back since we've already got one Time USB on display. All right, well, we got two batteries in, one up top, one down here. Now, unfortunately, I need to build up more cables and I need more fuses. And also, before any more can go on, I've got to fully charge them. They should be pretty close to being fully charged, but I'm gonna top them off anyway. We'll go ahead and put the Waldemar in because I do have one more fuse. So we'll have a total of 3 batteries. I've got fuses coming, so when they get here, I'll be able to finish putting all the rest of the batteries in. All right, you guys. So I've got 8 batteries on the shelf. I don't have them all hooked up. I only have 3 hooked up. So I've got the Waldemar that I fully charged just now. I've got the Time USB Pro and the Time USB Sturdy hooked up. So I'm still waiting on fuses for the rest of these guys. I'm not going to hook these up without fuses because I just want that added layer of protection since this whole thing is already a little sketchy. But for now, let's go ahead and turn on the inverter. I have a AC hooked up. And one thing that I do want to mention that I found out about inverters with GFI, they may not work with an air conditioner. This one didn't. The one that was in the Leesky inverter did not. It would trip when the compressor started. So I did some reading around, and there appears to be different kinds of GFCI receptacles. Some react fast, some react slow. And if you're going to put an inductive load like this on it, you need to you have the ones that react a little bit slower. Apparently this one reacts too fast, and if it detects any difference between the current between the neutral and the hot, immediately it will trip. Keep that in mind. I actually ended up replacing this one, which was what was in here, with just a standard dual gang, which is fine because my AC has a built-in GFCI. Inverter's on. Let's turn on the AC. We should have did that while we were over there. And I've got it on high, so it should use a lot of power. And this is what the shunt's saying. So we're using 74 amps, 1,030 some odd watts. And so while this is running, what I kind of want to do is just check all my connections, see if anything is getting hot. My wires, where the terminals are crimped on, you might have a bad crimp. You could have a bad, maybe something's not tightened. So whenever you build your system, like I always say, you need to run it hard and check everything. If you have a thermal camera, that would be perfect. I don't have one yet. I want to get one. All right, everything seems to be pretty cool. I'm not detecting anything heating up at all. Let me check underneath here. No. Everything is cool as a cucumber. Well, as cool as it can be. It's hot outside. Let's see, we are easily 100 and some odd degrees. All right, well, so let's go ahead and hook up some solar. Okay, so we're pulling in 44 amps on this guy, which doesn't equate to a whole lot, just 570 watts. You know, this is 12 volt, so that's the downside of 12 volt, obviously. It's big wires, big chargers, heat, lower actual power. This thing's not heating up quite yet. Now there it's getting hot, 103. But I'll show you, if this thing goes haywire, this relay will trip. I can turn it off manually right here. And you see that you know, we got a red light over here, meaning that we lost the battery connection. And so we stopped charging. But it's programmed, the shunt is programmed to shut that relay off if the voltage is above, I think it's 14.8 was what I got it set to. Here, let's turn it back on. I'll show you on the app where I set that. But the app, this shunt is really awesome as a battery monitor, guys. Showing our amp, our voltage, power currently coming out of the battery. Take a look at what I've got set on the shunt. You go to the protection settings, and let's see. We've got low temperature protection, so this will shut off at 1 degree Celsius. So that'll turn the charger off, so we don't charge these batteries while it's freezing. So that's awesome. Okay, OVP, over voltage protection. So I've got it set to 14.8. If the voltage goes above 14.8, this will shut the charger off and prevent us from frying our batteries and other equipment. So that's awesome. That's awesome that this shunt does this. Yeah, this guy's at 109, almost 110 now. And granted, you know, it is hot in here. It doesn't feel terrible right now, but I've left this thing on for hours and you can't even touch it. It just hurts. All right, guys, so I think for now that this will be the end of the video. I think this is all that I can do right now. I need to get the rest of the fuses in, and we'll get the rest of the batteries tied in. And I have a really sweet charge controller coming in, one that I've never used before, but it's a really super high quality one, and I'm kind of excited about it. Of course, we'll do a review video of that, and then we'll install it onto this thing. But tell me your thoughts in the comments, guys. If you can see any issues, I'd like to know. If you have any thoughts, I'd like to know. And again, it's really, I think we want to test these batteries. I've got them sitting here basically doing nothing after we do the initial review. There you go. Let me know your thoughts, and I'll catch you on the next one.